Okay, so let's review the warm-up and arithmetic sequences for a moment. So let's look at our pattern 3, 6, 9, 12. Now, one of the things that we should identify is that it is increasing, and because we know we're looking at an arithmetic sequence, which is kind of a gimme, then we know that it's either going to be addition or subtraction. And in this moment, we're talking about addition because it's increasing. So how did we get from term to term? So how did we get from 3 to 6? What happened? How did we get from 6 to 9? What happened? And how did we get from 9 to 12? So if we look, 3, 4, 5, 6, 6, 7, 8, 9, we know we're adding 3 to each term, 9, 10, 11, 12. So our common difference is going to be plus 3 for this particular problem. So now let's find the next 3 terms. So we have 12 plus 3, which gives the next term of 15. And then we have 15 plus 3, which gives the next term of 18. And then we have 18 plus 3, which gives the next term of 21. So there are the next 3 terms, and we have the first 7 terms. So this is A sub 1, just to review, A2, A3, A4, A5, A6, and A7 as the 7th term, just so we are moving forward because we're about to start working with this recursive definition. So let's write the recursive definition and then find the 8th term using the recursive definition. So A sub 1, so we know that A sub 1 equals 1 for the recursive definition, then A sub n equals A sub n minus 1 plus d, and that's for all the other terms. So A sub 1 for us equals positive 3, and then A sub n is going to equal we're going to write A sub n minus 1 again, and then we're just going to put plus 3 for the recursive definition. And hopefully I'm not moving too fast. Now, let's find A sub 8. Well, in order to find A sub 8, I am going to need the 7th term. So A sub 8, I'm going to need the A sub 8 minus 1 plus 3, which is going to give us A sub 8 equals A7 plus 3, which means the 7th term. So then I'm going to go to my sequence, and I know the 7th term is 21. So I know that A sub 8 equals 24. So the 8th term equals 24. And again, hopefully I'm not moving too fast. Now let's look at finding the explicit definition. So the equation for the explicit definition is A sub n equals A sub 1 plus n minus 1 times the common difference. So we found the common difference to be positive 3. We know our A sub 1 is positive 3, so we're going to put some substitutions in. So A sub n, meaning I can find any term. So just going back to that ticket out of the door yesterday, recursive, you're going to need that first term. In the previous term, you're going to need the previous term. For explicit, you can use the equation to find any term. So A sub 1 equals 3 plus n minus 1, right now I don't know what I'm looking for, times the common difference of plus 3. So now let's find the 24th term. So A24 is going to equal 3 plus, substitute in 24 in those parentheses, minus 1 times 3. And now let's do some math. So 3 plus 24 minus 1 is 23 times 3. And if you have a calculator, you can use a calculator. 3 times 3 is 9. 3 times 2 is 6. That's 69. So 3 plus 69, which gives us 72. 69, 70, 71, 72. Very good. Now, simplify the explicit definition. Now, this is on here because sometimes you will see the explicit definition in this form, and sometimes you will see it in another form. So we're going to go to the explicit definition that we found, which is A sub n equals 3 plus n minus 1 times 3, and we're just going to simplify that down a little bit more. So we're going to use the distributive property over here in the next step. So A sub n equals 3 plus 3n minus 3, and then we're going to combine those like terms. So A sub n is going to equal, we're going to write 3n again because there's only one value that has n, one variable, and then 3 minus 3 equals 0, so this becomes our simplified equation, and hopefully that's what you got for your warm-up.